Okay, so this is Unit 4 review. This is on parallelograms. Going over the unit review, this may not look exactly like your unit review that you took or will be taking, but also just know that this is just a review for you to prepare you for your test. Okay, so the first question, figure ABCD is a square. Prove BD, segment BD is congruent to segment AC. So always start off with the given, always end up with what you're trying to prove, right? So this sentence right here. It says that ABCD is a square. We want to prove that BD right here and AC right here are congruent. And looking at this next steps, right? So it says DAB, which is this angle right here. And ABC, which is this angle right here. And then BCD, which is this angle right here. And then CDA, which is this angle right here. They're all right angles. This is the definition of a square. And if they're right angles, then all of them equal 90 degrees because they're all congruent, right? So then it says, looking at the segments, right? AB, segment AB. So this is what we're looking at now. Segment AB is congruent to segment BC, which is congruent to segment CD and DA. So that's this part right here. And we want another reason for it. Looking at my options, right? The first thing is that all right angles measure 90 degrees. There's no way that segments can be the same because the angles measure 90 degrees, because I have this right here, this is 90 degrees, and those segments are not the same, right? This right here, that's 90 degrees, and those segments are not the same. They're not congruent, right? So that we're not even talking about angles, we're talking about sides. We're also not talking about diagonals because we're looking at the green line. So diagonals are not mentioned. And then perpendicular, same thing right here. I made perpendicular lines. Here is my angle, and there's no way that those two sides are the same. Or this one right here, those two sides are not the same. So you're left with one answer. Measurement of angle L in parallelogram LM and O. So you need to write this down. The thing you need to write down is that parallelograms opposite angles are congruent. Congruent, okay? So looking at this, I have my opposite angles right here and right there. I set them equal to each other. 2x equals 3x minus 20, right? Bringing all the variables to one side, I'm going to subtract 3x from both sides. This gives me a big 0. This leaves me with negative x is equal to negative 20. If negative x equals negative 20, then positive x should equal positive 20, or you could divide by negative 1 on both sides, right? There's my big one, okay? This is not the answer you are looking for, right? So what I'm looking for is measure of angle L. So I need to take this, plug it back in there. 3 times 20, which is what I found for x, minus 20. 3 times 20 is 60, minus 20 equals 40, and that's what should be your answer, okay? Another proof, given, right? So starting with the given and then ending with your proof that it's a parallelogram. Segment RT and TV, so that's these tick marks right here. This is segment, oops. This is segment RT, this is segment TV, and they're congruent. And then you can see by the tick marks that they are congruent, right? Then it says angle RTS, that's this angle right here. And then VTU, that's this angle right here. And it also says RTU and STV or VTS are vertical angles. They're opposite of each other. And then the next line says that they're congruent. So same thing because vertical angles are congruent, right? Then it's looking at Sas Congruency Theorem. So that is what we're looking for. How can, or what statement can we make with Sas, right? And when I look at this, if this is my angle, here I have the 1 tick mark, the angle, and the 2 tick marks, and there's my triangle. Here I have 1 tick mark, the angle, and then the 2 tick marks, and there's my other triangle. And when I look at my options, there's RTS and VTU, right? and the other ones are the side ones. So those ones are congruent as well. If I look at the other options, right? So here is RTS and RVS. If I take RTS, that's this, RTS, that's that triangle. RVS is here, right? So you can see that those triangles don't look the same. They don't even look the same, right? And for the most part, math doesn't really trip you out unless it says something about not to scale, right? So not even an option, or you can narrow it down. This one right here, they do look the same. So VRS, and VRU is the other option, right? They do look the same, but you only have one segment, this middle one right here, that is congruent on each one because it's the same line, right? The other ones you haven't been told anything on, so you can't just like make that conjecture based off of information that you don't know, okay? And the last one, VUR and VUS, VUR is right there, VUS is right there. So those triangles don't even look congruent at all. Not only do they not have the same angles or the same sides to be able to use SAS, but they just don't look congruent, and you can kind of base it off of that. Okay, Jacob is cutting a tile in the shape of parallelogram, so two opposite angles. So I like to draw this out. This opposite angle is 6n minus 70. This one is 2n plus 10, right? And what do we know about opposite angles in a parallelogram? They are congruent, so I can set them equal to each other. 6n minus 70 is equal to 2n plus 10, right? Here, I'm going to add 70 to both sides, right? All the constants to one side, all the variables to the other. This makes a big 0. Bring it down, 6n equals 2n plus 80. Subtract 2n from both sides. This gives me a big 0. If you have questions on this, on how to solve, I can help you. Equals 80. And then I'm going to divide both sides by 4. Right? Because 4 times what equals 80, and then you will be left with 20. This is not your answer, right? You got to plug it back in. So plugging it back in to any one of them, I like 2n plus 10 because it's just smaller numbers. Just plugging this in, 2 times 20 plus 10 equals 40 plus 10 equals 50. So there's my one angle. So this is not drawn correctly. They should be in the opposite ones. And then you know that in a parallelogram, because these are the same, so this one and this one is the same, right? You're looking at 360 degrees all together. So this part right here, each side should be 180 degrees, right? So this is the only option with 50 degrees. But if you take 130 here, and add them all together, 50 and 50, that will give you your 360 degrees, okay? Which concept can be used to prove that the diagonals of a parallelogram bisect each other? So that this one is talking about this, and this one's the same, and this one's the same, because it's bisecting, cutting it in half, right? Cutting it into 2 pieces. Congruent triangles, similar triangles, congruent rectangles, and similar rectangles. So first of all, the rectangles right here, there are no rectangles in this. They're parallelograms, so you know that that's not an option. And then congruent triangles, they have to be the same measure, right? Similar triangles, they have to have the same angles, but they could be different sizes. Congruent triangles, they have to be exactly the same. Parallelogram SW is 4 centimeters, right? WT is 6 centimeters, RS is 5 centimeters, and ST is 7 centimeters, right? What's the length of line segment WU? So you're looking at what is this one right here. They give you a lot of answers, but know that in parallelograms, your diagonals, they bisect each other. They cut it in half, right? So if this side is 4, then this side is 4 as well, right? And the same thing goes for the other ones. If this is 6, then this is 6 as well. If this is 7, then this is 7 as well, and then 5 as well, okay? So a lot of parallels. Okay. The rhombus is shown with its diagonals. Angle MLO, so that's this angle right here, is 112. So what is the measure of angle MLP? So you're looking at this one right here, right? And in this, right, when you have these diagonals, it's actually bisecting the angle. So bisect means this is 2, right? And this means, I think it means cut, right? So it's cutting into 2. Like bicycle is like 2 wheels on the bicycle. Bisecting means you're cutting it into 2 pieces. So if this whole thing is 112, then if you're cutting this into 2, it would be 56 and 56, and that would be your thing. Or 112 divided by 2. That's all you got to do. Okay. What is the value of P? Again, opposite angles are congruent. So if I use this, 4P plus 12 equals 36, right? Solving for P, I'm going to subtract 12 on both sides. This gives me a big 0. Bring down 4P equals 24. Divided by 4. This gives me the big 1, and P equals 6, right? And on YouTube, you can slow this down. So if this is going too fast for you, rewind it, slow it down, or pause whenever you need to. And that's the beauty of distance learning, right? In your classrooms, you can't pause your teacher, right? You can raise your hand and ask questions, but you cannot individually pause. And a lot of times I don't like asking questions in front of teachers because I feel like I'm slowing everyone else down, which is not true. But it's easy to be able to pause or slow down. I know I talk quickly, so if you just change the setting, and if you need help, I can send you a tutorial on how to change the setting to make me talk slower or faster if you need it. And you can figure that out, okay? So the value of P is 6. Okay, Juanita is cutting a piece of construction paper in the shape of a parallelogram. Surprise, surprise, parallelograms. This unit is on parallelograms. 2 opposite angles have a length of 5n minus 6, so 5n minus 6, and 3n minus 2. Sides, sorry. 2 opposite sides of the parallelograms. So 5n minus 6, 3n minus 2. The third side measures 2n plus 3. Okay, so what are the lengths of the 2 adjacent sides? Adjacent means next to, right? So you're looking at this side and this side, they're next to each other. How I do this, right? So parallelograms, opposite sides are also congruent. So I can put 5n minus 6 is equal to 3n minus 2. So I'm setting these 2 sides equal to each other, right? Bringing everything over to one side, subtract 3n, subtract 3n. Whatever you do to one side of your equation, you have to do the other, right? This gives me 2n minus 6 is equal to negative 2. Add 6 to both sides. This gives me a big 0. I am left with 2n equals 4. And this, if I divide both sides by 2, this will give me n equals 2. Okay, so I take this answer, right, and I plug it into my originals, right? So here, if I were to plug it in, this would be 2 times 2 plus 3. This gives me 4 plus 3, which is 7, right? This is my, I got 2 options that have 7, right? So then I take it, n equals 2, and plug it into the other ones. 5, 2 minus 6. This is 10 minus 6. This equals 4. So my 2 sides that are next to each other are 4 and 7. Okay. Question 10. So 15 meter by 23 meter garden is divided into 2 sections. 2 sidewalks run along the diagonal of the square section and along the diagonal of the smaller rectangular section. Okay, diagonals. Here are your sidewalks. These are gardens. So here is my grass. There's grass. Okay. The way I would do this is Pythagorean Theorem, is what you guys have learned already. So it says, what's the approximate sum of the lengths, right? And the cool thing is they give you decimals, so you don't need to keep the square roots, okay? So first thing we need is this triangle right here, right? So this, if this whole thing is 23 and this square section is 15, that means that this piece is 8 centimeters, oops, meters, and this is 15 meters, right? Looking at this triangle, I've got this triangle right here, which is, I want to know the hypotenuse, which is C. I got 15 meters and 15 meters. This one on this side, oops, this is 8 meters and 15 meters, and I want to know what this option is, and then I add them together, right? So Pythagorean theorem is a squared plus b squared plus, not plus, equals c squared, right? So I just plug in 15 squared plus 15 squared equals c squared. Take my calculator. This is 225 plus 225 equals, oops, 25 equals c squared. So this is c squared equals this 450, and c equals the square root of 450, right? So this one right here, if I take the square root of it on my calculator, sorry, you can't see, I'm not opening multiple tabs. So if I take my calculator that I have access to on Edgenuity, and I take the square root of 450, this will give me 21.2-ish. So that's one right here. This one is 21.2 for that part, and then I need to find the other one. So same thing again, on the other side, I would do 8 squared plus 15 squared equals c squared. So this would be 64 plus 225 equals c squared, right? 8 times 8, and then 15 times 15. This is 289 equals c squared. And if I take the square root of that, of 289, this will give me 17. That's a perfect one, right? So this is 17. And then all I do is add them together, right? So it's 21 and 2/10 plus 17 will give me this number right here, okay? So if you have any other questions on that one, let me know. Okay. Almost done. Okay, diagonals of parallelogram are congruent. Which could be the parallelogram? So looking at this, trapezoids, kites, and rhombuses, right? So if these are not regular ones, then you don't know if they're congruent. But you do know, so I'll show you an example, right? This is also a trapezoid, right? So then you can see that this one, this diagonal, and this diagonal right here, they're not the same. And so that one is not. This kite right here, if I have a kite, and I have this diagonal, and those are not the same, right? And the same thing if I had a rhombus like this. Oops. A rhombus, right? This side and this side. Well, that kind of looks the same, but it's not. And then the rectangles, if you have a rectangle right here, right? That diagonal and that diagonal for sure are the same. My drawings aren't that great, but that's just the definition of it. It should be in your notes. Okay, this one again. What's the measure of angle? Oh, so looking at this again, opposite angles are congruent. All of these angles equal 360, right? So if I look at this part right here, it's got to equal 180 degrees, right? Because this 180 and these 180 equals 360. Okay, so x plus 40, I'm not setting them equal to each other because they're not opposite of each other. Plus my 3x equals 180. Combine like terms, I've got x and I've got 3x. This gives me 4x plus 40 equals 180. Now I can solve, right? Subtract 40 on both sides. This gives me 4x equals 140. Divide by 4 on both sides. and I will get, I don't know, 140 divided by 4 equals 35. Right? This is not the answer we're looking for. We're looking for measure of angle O. So if I take this, plug it back into angle O, 3 times 35, this will give me 105 degrees, which is my answer. Kind of tricky because you're solving for X and then you think that's your correct answer. In parallelogram, PQSR, what is PQ? So PQ, we're looking at this one right here. They are congruent to each other because they're opposite sides. So 2x plus 5 is equal to 4x plus 1. Doing the same thing again. So I'm going to subtract 2x on this side from each side. The reason why I do that is because I like positive numbers, and I can do 4 minus 2, this equals 2x, right? If I did the other way, it will give me negatives. 5 equals plus 1. Bring everything else down, okay? My next step is I'm going to subtract 1 on both sides. This gives me a big 0. This leaves me with 2x equals 4. Divide both sides by 2. This gives me x equals 2, right? And then plugging that back into there, I would do 2 times 2 plus 5 equals 4 plus 5 equals 9 centimeters. Okay. So let's fill in. WY is this whole thing, so that's 12, and you know it's bisecting because it's a parallelogram, so this should be 6 and this should be 6. XZ is 16, so this should be 8 and this should be 8 to make 16. WX is 10, and then XY is 9, so opposites as well. What's the length of the line segment MX? Oh, okay, they give me a lot of information, but you only needed to know that this one was 16, so cutting it in half, bisecting it would be 8. And the last one, which angle measures are correct? Select 3 options. So this is 125. This one is just 125 as well. And then also knowing that these 2 angles form 180, they're supplementary. If I take 180 minus 125, this will leave me with 55, and congruent opposite angles is 55. So measure X is 55, measure W is 125, measure Z is 55, and yeah, okay. So a couple things that you need to know for this one. Parallelograms, the diagonals, they bisect each other, opposite sides, opposite angles, those are congruent, which means they are equal to each other. And then also, so those are opposite of each other and they're congruent. But if I just looked at this one side, right, the whole thing equals 360. So this part is equal to 180. Only in parallelograms, right? That's the definition. And then in proofs, what you're looking for is just narrowing down which ones are the wrong answers. Okay, good luck. If you have any questions, please, please, please just email me. I'm here.